Hi everyone, welcome to Digital Dynamo Lab. In today's session, we are going to learn the transmission medias in computer network. Let's start the session. What is transmission media? Transmission media is the physical path or channel that connects the sender and the receiver. It's the route through which data travels from one device to another. This path can be wires like cables or wireless signals like Wi-Fi or Bluetooth. Transmission media having two types like guided media and unguided media. Guided media again divided in three types: twisted pair cable, coaxial cable, fiber optic cable. Now this unguided media again divided in three types: radio waves, microwaves, infrared. Now let's discuss all these medias in detail. First one, guided media. Guided media uses physical wires or cables to transfer data between devices. It forms direct physical link between the sender, transmitter and the receiver. It is mainly used for shorter distances, which means the signal cannot travel as far as wireless communication. It provides high speed and is generally more secure because the data stays within the cables and is harder for outsiders to intersect. Types of guided media: twisted pair cable, coaxial cable, fiber optic cable. Twisted pair cable. A twisted pair cable is made of two copper wires twisted around each other. See this image. Each wire is covered with its own insulation so they don't touch. The twisting helps reduce interference from other signals, making the connection clearer. The first type of twisted pair cable is unshielded twisted pair cable. Unshielded twisted pair is a type of twisted pair cable commonly used in telecommunication and networking. It's low cost, easy to install and support high speed data transfer. Advantages of unshielded twisted pair cable: least expensive compared to other networking cables. Simple installation without complex tools. High speed capacity for data communication. Example: Ethernet cables used in homes and offices. The second type of twisted pair cable is shielded twisted pair. Shielded twisted pair cable is a type of twisted pair cable with an extra shielding layer around the wires to protect signals from interference. It is mostly used in Ethernet networks, industrial control system and medical equipment. It offers a higher data transmission rate compared to unshielded twisted pair. Installation is still fairly easy but more expensive than unshielded twisted pair. Advantages of shielded twisted pair: better performance at higher data rates than unshielded twisted pair. Eliminate crosstalk. Faster data transfer compared to unshielded twisted pair. Disadvantages of shielded twisted pair. More difficult to install and manufacture than unshielded twisted pair. Higher cost, bulky and less flexible to handle. Example, used in places where signal interference is high, such as factories or hospitals. Coaxial cable. A coaxial cable has a unique structure. The inner conductor is made of copper which carries the signal. Around it is a non-conductive insulating layer to separate it from the outer layer. The outer conductor is made of copper mesh which acts as shielding to reduce interference. It supports higher frequencies compared to twisted pair cables. Coaxial cables are easy to install but more expensive. Types of transmission in coaxial cable. First one, baseband transmission. Sends one signals at a time at high speed. Commonly used in local area networks. Second one, broadband transmission. Sends multiple signals at the same time at high speed. Used in modems and TV systems. Advantages of coaxial cable. High bandwidth. Can carry a large amount of data, making it suitable for high-speed communication. Easy to install. Can be set up without much complexity. Reliable and durable. Works well for a long time without frequent damage. Less affected by interference. Resist noise, crosstalk and electromagnetic interference. Support multiple channels. Can carry several signals at once. Disadvantages of coaxial cable. Expensive. Cost more compared to twisted pair cables. Must be grounded. Needs proper grounding to prevent interference or crosstalk. Bulky. Multiple layers make it thicker and harder to handle. Fiber optic cable. A fiber optic cable sends data as pulses of light instead of electric signals. It works best for long distance data transmission and telecommunication. Can carry a large amount of information at very high speeds. It is expensive and difficult to install and maintain compared to copper cables. Core, the central part that carries light signals. Cladding, a thin layer around the core that reflects light back into the core, helping it travel. Coating, protects the core and cladding from physical damage. Strength member, keeps the cable safe from damage during installation. Outer jacket, protects the cable from environmental damage like moisture or heat. Applications, internet connections, telephone networks, medical equipment, computer networks. Advantages of optical fiber cable: increased capacity and bandwidth, can carry much more data at higher speeds than copper cables. Lightweight, easier to handle compared to heavy metal cables. Less signal attenuation. Signals travel longer distances without losing strength. Resistance to corrosive materials. Disadvantages of optical fiber cable: difficult to install and maintain, requires special tools and skilled technicians. High cost, more expensive than traditional copper cables. Unguided media. Unguided media, also called wireless or unbounded transmission media, is a method of transmitting data without using any physical cables. Instead, data is sent through electromagnetic signals traveling in the air, water, or even space. Features of unguided media: the signal is broadcasted through air. Data travels as radio waves, microwaves, or infrared signals instead of wires. Less secure. Since signals travel openly in the air, they can be intercepted by unauthorized users. Types of unguided media: radio waves, microwaves, infrared. First discuss radio waves. Radio waves are a type of electromagnetic wave that spreads out in all directions through free space, air. They are used for communication over wide areas, such as cities or even larger regions, wide area networks. Their frequency ranges from 3 kHz to 1 GHz. Radio waves can carry data at relatively high speeds. The senders and receivers at antennas do not need to be aligned. The signals spread freely. This makes radio waves great for multicasting, where one sender broadcasts to many receivers at once, like in radio or TV broadcast. Radio wave have two components, transmitter and receiver. Transmitter, this part takes the original information, like sound or data, and convert it into radio signals that can travel through the air. Receiver, this part captures the radio signals and converts them back into the original information so it can be understood. Applications of radio waves: FM radio, sending music and news broadcast to radios in homes and cars. Mobile phones. Television, transmitting TV signals over the air to your TV set. Microwaves. Microwaves use antennas to send and receive data signals. The distance the signal can travel depends on the height of the antennas. Their frequency ranges from 1 GHz to 300 GHz. which allows them to carry large amounts of data. Satellite microwaves can communicate globally by sending signals between satellites and devices anywhere on Earth. Applications of microwaves: mobile phones carrying wireless voice and data signals, television networks sending TV signals via satellite or cable networks, satellite networks providing communication services worldwide through satellites. Advantages: cheaper than using cables. No need to lay expensive physical cables. You don't have to buy or rent land to install cables. Works well in mountains, forests or other hard to reach places. Communication over oceans. Ideal for sending signals across large water bodies where cables are not practical. Disadvantages: insecure communication. Signals can be intercepted more easily by unauthorized users. Out of phase signal. Signal quality can degrade if waves get out of sync. Bad weather like rain or storms can weaken signals. Bandwidth is limited. Can carry less data compared to wired media. High cost of design, implementation and maintenance. Setting up wireless systems can be expensive and require ongoing upkeep. Infrared. Infrared is a wireless communication technology used for very short distances. Its frequency range is from 300 GHz to 400 THz, which allows it to carry data quickly. However, infrared signals cannot pass through obstacles like walls or furniture. It offers high bandwidth and is considered secure because the signals don't go far. Infrared supports a lower data transmission rate compared to other wireless types. Applications of infrared: TV remote controls, sending commands to your television, data transfer between two mobiles, quick file sharing over short range, wireless devices like mouse, keyboard and printers, connecting peripherals without cables. Thank you for watching. Like, share, comment and subscribe to Digital Dynamo Lab for more tech explainers.